In this video, we're going to take a really quick look at the basics of frequency distributions. So first of all, a frequency distribution, also known as a frequency table, is just a very common way that we organize data. And we do this by listing the classes or the categories in one column, and then listing the frequency or the number of times that particular data value occurred in the other column. They are often used to summarize large data sets. They can help us identify patterns or any gaps or some possible outliers. And a lot of times they are used as the basis to create some of our other charts and graphs that we would use. Now, classes is one of the terms that was in the definition of a frequency distribution. And we use the term classes to identify the the category. Now, if we are looking at quantitative data, so data that represents numeric values or that represents counts of things, we can either have our classes be single value classes or they can be a range of values. So now a single value class, an example would be if I asked people how many siblings they had. Most people are probably going to give us an answer between 0 and 5. So my frequency distribution, okay, I would set up my possible values here. So you could have 0 siblings, 1 sibling, 2, 3, however many however far you would need to go. And then we would have our frequency in this other column. And then we would record, well, how many people said they had 0 siblings. So maybe there were 6 people that had 0 siblings. Maybe 12 people said they had 1 sibling, and maybe 15 people said they had 2 siblings, etc. So this would be an example of a single value way that we categorize it, because our categories over here are just individual values. Now, if our data set is larger or has a lot wider range of values, then we might want to use a range of values for our classes. So if we look at the table that just popped up here, let's say that this represents 400 meter dash times. So in the left-hand column here, I have my categories, and these represent the times, and then my right-hand column represents the frequencies. So this table is telling me that there were 2 people that ran between 55 and 64 seconds. And there were 6 people that ran between 65 and 74 seconds. So notice that our categories are not just an individual value anymore, they are a range of values. When we have this type of a table, we have some other vocabulary that goes along with it. Okay, sometimes we might need to know what the lower class limit is. And the lower class limit, if we think of the terms in there, lower means smallest, class limit, well, the class, we're talking about our different categories over here. We can call them classes. And limit tells us that we're looking at the endpoint. So we're looking at the lowest limit for a particular class. So in our particular example, we would have 55 would be the lower class limit of the first class. 65 would be the lower class limit of our second class. 75, 85, and 95. So they would all be considered lower class limits. Now we also would have upper class limits. So if we look at the terms there, it's the same type of thing, but now we're looking at the upper end, the higher end. So in our table over here, our upper class limits would be the 64, 74, 84, 94, and 104. Those would all be upper class limits. Okay, now sometimes we need to know what class boundaries are. Now the class boundaries, if you think of running a 400 meter dash time, where would somebody that ran 64.8 seconds, where would they fall in here? Because our first class says it's from 55 to 64. Well, this is above 64, but our second class is from 65 to 74. Well, this is below 65. So what we would do is we would use what's known as a class boundary. Those are going to be the numbers used to separate our classes. Now the easiest way to visualize this is through using a number line. So if I were to plot some of my class limits here, Let's say I have 55 there, I have 64 here, and then I have 65 right there. Well, our class boundary is going to be a value that's in between our classes. So my upper class limit for my first class was right here at 64. My lower class limit for my second class was 65. That's right here. So our class boundary is going to be the value that's right in between them. Well, halfway between 64 and 65 is 64.5. So that's going to be my class boundary. That's going to be the value that I actually use to separate them. So we would just use general rounding rules. If we have anything that's below 64.5, we would put it in our first class. We would say it goes with the class below it. If we have 64.5 or above, we would end up putting it in the second class. So this allows us to eliminate any gaps that are created by these class limits. Now we also have class midpoints. That is the midpoint, so the middle of a particular class. Now to find it, we would add the lower and upper class limits of a particular class and then divide it by 2. So for example, if we wanted to find the midpoint of our first class, we would take 55 plus the 64, divide that by 2, and that's going to give us 59.5. So that would be considered our class midpoint for the first class, and we could do that for any of these classes up here. Okay, and then the last one that we're going to look at right now is class width. Now here's one that people often will make an error on. It's the difference between two consecutive lower class limits. What people want to do a lot of times is they want to subtract the lower class limit and the upper class limit, and that's not going to give you the correct class width. We need to subtract two lower class limits that are right in a row. So in this case, we could do the 65 minus 55, and that would give us a class width of 10. Okay, so when you're doing your class width, make sure that you use two consecutive lower limits to find that value. Now there are going to be times when you're asked to make your own frequency distribution from a data set. So we're going to just look at a generic example here using a quantitative data set, meaning these values over here represented counts of some type of items. Now, there's kind of a general process that you go through. The first thing you want to do when making a frequency distribution is you want to determine the number of desired classes that you want to have in your table. Most of the time that's going to be between 5 and 20. The next thing is that you want to calculate what the needed class width is. So now in order to do this, you would need to take your maximum value minus your minimum value from your data set and then divide that by however many classes you decided that you wanted. And then you're going to round this value up to the next convenient number. So if we look at our data set here, and let's just assume that this is our maximum value of 42, and it looks like our minimum value is 12. And let's assume that we want to have 8 classes. So in order to find what my class width would be, I would take 42 minus 12, okay, and that's going to give me 30, and then I'm going to divide that by 8 because that's how many classes I want. Well, when I do 30 divided by 8, I get 3.75. So it says to round that value up to a convenient number. So I'm going to round this up to 4. I usually don't want to use decimals for my classes unless it's appropriate for the data set. So if my data set had decimals in it, it would make sense to use decimals for a class width. But since it looks like I have all whole numbers, I'm just going to round this up to the nearest whole number of 4. Now that is not the only possible class width you could have used. You could have used 3.8 if you wanted. You could have used exactly 3.75. You could have used 5 if you wanted. So the idea here of a convenient number, there's no hard set rule for what that convenient number should be. Okay, so once we figure out our class width, now we have to choose what our first lower class limit's going to be. So in this case, since 12 is our minimum, it either has to be 12 or a number below 12. So I'm going to start with 10 for my first lower class limit. And then I want to now construct the classes using this very first limit, lower class limit that I selected, and then my calculated class width. So remember, the class width is the difference between consecutive lower limits. So my next lower limit would be 14. And then I would have 18. And then 22, and so on. Once I get those lower class limits put in here, then I want to go back and I want to fill in my upper class limits. So since 14 was my lower class limit here, and I'm only dealing with whole numbers, it looks like, 13 would be my upper class limit for my first class. And then since 18 was my lower limit here, I would have 17 for my upper class limit, and so on and so forth. Once you get all of your classes put in there, then you will need to go back and you will need to figure out the frequencies. So I would come back to my data set and I would count how many values are from 10 to 13. So in this case I have 1, 2, so I would have a frequency of 2. And then from 14 to 17, I would count how many values I have and put that value in here. And then I would count from 18 to 21 and do that for every single class that I have. And that will produce one version of a frequency distribution for a data set. Now this would not be the only frequency distribution for that data set. If we had changed the class width, or if we had changed our lower class limit, this table would look different. Now, there are going to be times when we have qualitative or categorical frequency distributions. So qualitative occurs when we have non-numeric topics. So in this case, we are apparently looking at the favorite sport and football, volleyball. These were non-numeric values. Now don't get confused by the numbers over here, because sometimes people will look at these and they'll see numbers so they assume that it's quantitative. But remember, these are the frequency counts. So this is telling me that 25 people selected football and 18 people selected volleyball. So my categories over here, the sports, are non-numeric. But we still have the same concept where it's showing us how many people fell into each of those classes. Now with qualitative, we don't have a lot of those other things like the class limits, the boundaries, the midpoints, because it doesn't make sense to do that with qualitative data.